Swayam Prabha. Digital India. Educated India.
Today we will be covering design elements of O languages. Okay. Now, how many of you are good in Java? Most of you, or not all of you, right? Some, okay. Which other O language you are familiar with? C++. So you are more proficient in C++. Is that so? Okay. Not all of you. Okay, 50% are C++, 50% Java. But C++ guys, you know at least to some extent Java, or you know, right? Perfectly fine. So I tried to be in fact independent of language as such. I mean, it is not that. Okay, so what we will cover today is broadly, I mean, it may not be in this particular order, but yes, we will cover types expressions and polymorphism, object oriented languages and programming as such, I mean, overview of that. Mostly we will concentrate on polymorphism and various basically dimensions of or kinds of polymorphism. Okay. Now, I myself actually I have worked on earlier on this, I mean long back rather to say, on compilers and all for Ada language, where the first time I came across in 94 about this polymorphism, generics and all this thing, that was basically the way it was introduced in Ada. Yes, many languages now, most of the languages support this generics. C++ has template, and then there is a Java has again generic as such, they call it as a generic again. So all these languages support this particular polymorphism in different forms. It is not only the template is the only way that okay you can define the polymorphism or whatever the currently people call it as a generics as such. Polymorphism has different dimensions, and we will basically cover most of them. Another part here to be remembered is that polymorphism actually, yes, I mean we will be in fact covering from the object oriented perspective, but yes, it is actually originated in functional programming, and in fact it is necessary that we should touch upon type expression, type systems in much more, not in detail as such I will go, but at least we should understand how this polymorphism evolved, what is the relationship with the type system and all, and that is what we will cover. And so this particular is a major in fact focuses on polymorphism. We will cover definitely some aspects of object oriented object orientation as such, and object oriented programming and object oriented languages, etc. So briefly we will cover that, and why this polymorphism is important I will just touch upon those aspects also. Okay, so it is okay if you are either you are familiar with C++, Java, does not make a difference, and most of the things should be clear, but let me start with one simple question here, and or two, maybe you can choose either of that, and let me see that how fast you can really solve it. You do not require a computer, you require only paper and pen. So just see that whether you can really, as you know C++ or Java, whether you can solve any of this problem in 5 minutes. Just you have 5 minutes, and let me see that if at least one of you can solve it or all of you can solve it, I will be happy. Let me read it. Are you able to read it? Okay, so what we are saying here is that, right, you can choose either of that. You do not have to solve both of them, but if you solve both of them, that is a great. Then write a Boolean function is elim in, we will call it as a f basically, or if is elim in, to determine if an object of type T is in an array passed as another parameter whose elements are of type T. Okay. So example is given, f can be used for both is 2 in this one and is Vivek in this particular array. You can use a meta language, you need not use Java, C++ also, but if you can do it to any of these languages, that's okay actually. Either you do that and you tell me after you do it. Okay, let's give 5 minutes, all of them think about it and you tell me after 5 minutes. It's not a problem if you discuss it, but in low voice. If you scribble on paper, that will be great, rather than just telling me the answer. If you can tell me answer also orally, that's perfect, but if you write it on a paper, that will be better actually. Yes, if you can both, that is great. If you have solved at least one, that will be, I will just stop after 2 minutes. Let's stop, and any one of you want to, okay, let me just say, you were asking that if should we solve second one, right? Just let me see what you have done in the first. So I have, in fact, what I have mentioned here is that it should work for both, either it is, whether it is a string array or whether it is a number array, it should work either for either of that, right? I mean, it should not be just for integer or this one. Will it that work? It will not work for other types, right? It will not work actually, think about it. Okay, but it is, I want a more generic answer. Anyone? Anyone wants, sorry? Okay, anyone has solved that, actually solved it completely? Any one of you? Tried it, not bad. I mean, you are at least near. So, okay, so this is where we are going to talk about generics, polymorphism and all these things. So, what we are saying here, if you look at, just let's go through these problems again once more. Okay, what we are saying here is that there is a basically a, definitely the first thing is that we have mentioned here is that determine if an object of type T, okay, T is basically mentioned here, that is it can be any type, right, and we will talk about this more later. T is a type variable basically here, okay, and what we are saying is that is in an array passed as another parameter whose elements are again of type T, okay. So that's what we are saying there. So one thing is that most important part here is that T, which is a type variable, we are not restricting it to the particular type. Now obviously there will be certain constraints that we are also mentioning, and that we will talk about that, what constraints and all this thing, that let's talk about that later. Second part, it's mostly we will talk about this particular part again when we say, generally what we observe is that we are talking about the functions as parameters as such, okay, functions as a parameter, second order functions as they are called it. Functions as a parameters, when they are they exist basically, then there is some other we can get a more general kind of approach for solving the algorithm, okay, and that's basically second. Again you can see here that we are mentioning that filtering objects of type T from a list whose elements are of type T, okay, T we are not restricting it to the particular type, okay. So this is where the polymorphism, in fact most of the time when we talk about the polymorphism, first thing people say is are we talking about a generic algorithm which can work for any type, or a typical type set of types which have certain constraints defined, and that's basically the idea of polymorphism. It has many forms, okay, the algorithm can have many forms, okay, and based on certain definition of that particular statement and the overall basically the restriction that we are mentioning. Okay, so before we talk about the polymorphism, let's try to understand more about types, okay, and the type system and the type expressions in programming languages, okay. So before, and obviously the first thing that comes when we say type, there obviously there is something called as the untyped, and then we talk about the type. So what is the untyped? Untyped, when you consider that the bit strings, okay, in a memory, you cannot make out anything from that. There is no interpretation that that it attached to that bit strings in memory, okay. Only when that bit string is actually representing maybe an integer, when we say that okay it is representing integer, then you can interpret the contents. but as such a bit strings in memory we cannot actually understand what it actually is representing, correct. So, that is a untyped, that is untyped, we do not have the really what we are saying here, what is being represented is not known, right, and that is where the untyped world comes. That untyped, basically untyped universe. In fact, this type theory, by the way, is a big subject by itself, and we will not be covering all the aspects, but we will be touching upon some aspects of it to understand the polymorphism and how it actually is impacted by this, all these things. Okay, so bit strings in computer memory is definitely it's just a piece of raw memory, and we cannot tell what is being represented. And in fact, we know that okay, this is the bit string when it is properly in fact grouped, okay, and then it becomes an integer, character, or whatever it is, right, and we can say that is basically what we are going to talk about when we say typed as such. There are many examples of untyped. Let us go to the next part here. Now, we want to more concentrate on type. Type is, what is a type? Type, we know in programming languages we always use that integer, we use float, we use maybe other types as such. Type is basically nothing but a set of elements, okay. It is there is some particular behavior is also attached, and there is a uniform behavior they exhibit, and that is basically type. So, when we say integer, there is a certain behavior is expected out of that. When I do a 5 star 10 or 5 star I representing a variable of integer, there is a typical behavior is expected, and that is basically the uniform behavior is very important. It is a basically set of elements. These elements can be, in this case I am talking about an integer, but the type, when we talk more about it, it can be type of something else also. It need not be just the simple integers, right. So, now there is a very interesting part now. Actually, this integer is a commonly used type, right. How many of you know JavaScript? Most of the time JavaScript kind of languages, they do not have that integer and real differentiation, they talk about the number, okay. And that actually is what is the basically why they are not having this integer and real as a different thing, why they are just saying that okay, number as a type. It depends on the language actually, and obviously there is a need for that, but why this purpose, what is the purpose of that language, according to that this types are introduced. Maybe COBOL has a decimal that is not there in any many languages, then there is a fixed point in ADA kind of languages which is used for avionics and defense kind of programming. So, that is important there. So, then there are obviously the Fortran and all, it concentrates more on mathematical kind of types. So, all these types, and in programming languages they are defined according to the language, that for the purpose of the language actually, and it is sometimes it is a string manipulation is important, then you define the strings as a more popular thing. Pascal and all they had also set as a one of the type. So, it definitely it is a depending on the language that this particular types are defined in that language. Now, most important, they should exhibit uniform behavior, okay, and that is a basically important thing, okay, and that is what type actually is. Whenever we say it is a strongly typed language, okay, or it is not strongly typed language, that is differentiated according to what is that uniform behavior means in that language, okay. It need not be same in all the languages. Some languages may allow integer and float to be mixed, some languages may not allow, okay. That uniformity has to be there according to the language. Any question? Okay. So, you can ask question at any point of time, okay. If you have any doubt question, please ask, do not worry about it. So, we are focusing today on OO. So, let us do one thing, let us park this question, okay. This correct, perfectly fine, not a problem. So, you park that question, we will talk about it later. Definitely you can ask the whatever current topic, let us ask the question at this point. Okay, till this point is it clear? Any question? Okay, fine. So, now when we say about the type system as such, okay, now we talked about the type, okay, what is a type system? Now if you look at this languages, they have this if, for, while, all these statements, okay. These statements, they have this particular expressions, okay, and those values of those expressions are important, but these values has to be of particular type, correct. They have to be of particular type, and this type expression actually is a type system, is a basically a set of rules assigning type expressions to these different parts of this program. Okay, that is a type system of this language, that X is this is a type system of this language, this is a type system of this language. That difference will be always there, that we follow that, okay, this if expression in C, it is just the integer, and the value of that integer can will determine whether it is a, we should continue with the then part or else part, whereas it has to be Boolean in Java or other languages, some of the other languages, right. So that type system actually is a basically set of rules assigning type expressions to different parts of program. Now type expression is another term that I have used here. Type expression is here basically what we are saying here is a simple thing, is a Boolean, is a type expression, but type expressions are the very important thing when we actually now we are getting into the polymorphism and all. We will talk about that. Now this particular part is very important, type system. Whenever you are writing a compilers and all, type checker in a compiler is supposed to in fact ensure that your basically program is compatible with the type system defined by that programming language. So there is a type checker in compilers. Okay. Now, okay, so we have talked about this basic types, character, byte, shorthand, and depending on the language they will be there, and some of them, some of the languages may have some different types as such. Fixed point will be there, as I mentioned, some of them may have a decimal, etc. So those basic types they are called, we will see that more about them. Now what are the operations common in few of these types? For example, integer and long and float, some of the operations are common, okay. Star is, multiply is common, addition is common, even strings actually and integers in some languages addition is possible, correct. So this I mean, that is basically concatenation, that obviously that actually meaning will change, but the operations are definitely similar. You may be using the same operator for doing that operation, correct. How the values of these various types are further formed is basically very important to understand more about this type system as such, okay. And that is a important thing for the type checker to know, that okay, overall this set of combinations of this particular types, how they basically are evolving the different values and different basically how the type relationships exist, okay. Type relationships exist, that is important for the type checker to understand, okay. So up to this point, is it clear? Any question? I will ask this, yes please. You have to be a bit louder, huh? Sorry.
Different types for a number. Why can't we just have one type and not having this integer and double and short int? Why can't we just have one type for defining?
Okay, so why can't we? Why should we have a discrete? So let me put it this way. First of all, why should we have a discrete kind of numbers and the continuous numbers? Correct. That's the first differentiation, right? Discrete numbers are 1, 2, 3, 4. That is the natural numbers we have, and then it may be the integers can be in fact negative side also, because we want actually to represent, let us say, some of the things, maybe a quantity of the bottles here, number of bottles here are basically integer, they are discrete, they are not continuous in nature, right. They are definitely discretely identified, and that discrete nature, the loop I execute I execute it for 10 times, okay. I do not execute it as a continuous thing. So there is a difference between the calculations or the what I require actually, and the second thing is that overall arithmetic that is performed by your computer, okay, that also differs actually. So, in the case of continuous or the maybe a real or float or this kind of types, the arithmetic may not be that accurate for certain things. Okay, there is a precision that is attached there, correct, and we do not want that, we do not want a exact actually this when we talk about a discrete, we want the exact numbering to be followed, exact basically calculations values to be there. Okay, we do not want that particular precision factor to come into picture. Okay, so there is a need for definitely a discrete way of measuring certain things, and there is obviously there is a calculations that the arithmetic that is performed in your hardware, that also is a important thing. Okay, both the things actually are so that's the way it evolved actually, and that's the way it is required, and that's the way it actually helps you to in fact write much better program. Okay, that's the reason they are different. In fact, JavaScript and all, you don't do the calculations actually. There is a difference in the case of those languages. So that kind of languages do not require that. So that's why they do not have that actually. Now, why the fixed point is required and why floating point, that is also you can find out that actually more. In fact, there is a very interesting story about that fixed point and the floating point. You can do the Google about it. Because of this particular inaccuracy in the floating calculation, what has happened is to that Mars rover, you can just look at that actually. There is and then the Pentagon has missed that missile has missed the target because of that floating point calculation they used. They did not use the fixed point calculation. So you can check that in Google, very interesting, and that's where the fixed point is a very important actually type in ADA kind of languages, where you, and there is obviously a library in case of Java and all, but this is a basic type fixed point where you define that, okay, I need a precision up to this point. Okay. So type system, we talked about that type system, that is a set of rules assigning type expressions to different type parts of the program. As it mentioned here, type expression to switch statement and if and while statement is different, correct, and that's basically the type expression. Now let's elaborate more on this type expression, as it is going to be more important. When we talk about expressions in a language, right, what is basically the what ultimately we get is the value out of that expression, correct. It's expressions, what we get is a value. Now to associated with this expression, as we have said earlier, there is a type expression also. Okay, and that's what the type checker is supposed to perform. For example, here we have this J, this 0 in the front is basically a bullet. Okay, don't worry about that. J equal to I star 50. Okay, J equal to I star 50. Okay, that's basically a statement. Now, what is the type of this value expression in a language like Java? Sorry? By default it will be double? Not exactly. Sorry? Value of the I will decide that? Okay, right, perfect. Not always, but yes, I mean sometimes it will be decided by type of I, not value of I, type of I, right? Okay. So, in fact, let's look at this. If I is float, then obviously this is good. This, what is this particular expression is? Float into integer float, to float. So, the type expression can be that float comma maybe a integer gives rise to float, right. You can see this bottom part also, right. Okay. Float, then if integer I is integer but J is float, then what happens in this case? I star 50, the value that is calculated after I multiplies I is multiplied by 50, that actually is converted to float. That so I star 50 still remains an integer expression, but that when it gets assigned, it becomes a float. Okay, we will talk about this particular kind of automatic casting kind of thing. Okay, it is basically called as the coercion. Okay, we will talk about that later. and this is a, then another thing is that both of them are int, obviously it will be int star int. So this is what it is, float star int float, int star int float, int star int or float star int float. Okay, this various combinations can be there. So in case of Java, actually int can be in fact promoted to float, okay, gets promoted to float depending on the type of operator and the type of different basically other operand. Okay. Now consider this particular part itself, above part itself. Now I want to now actually assign, okay, I want to assign to this particular type expressions, I want to try to generalize them and combine them, and when I try to combine, I will assign certain kind of variables, and the Greek variables are generally used in such cases. So I am using that, but it just so I am saying here alpha star beta gives rise to alpha, where alpha obviously and beta there will be certain constraints. Now this is what is exactly I am just looking, just look at the above this float star into float, int star into float, etc. If you look at that, it is actually what we are saying is that if alpha is from this particular kind of operand and beta is of this operand, then alpha star beta actually is alpha. It can be in fact a short also, it can be it automatically short will get promoted to int, and all these things will happen. We will talk about the subtyping later, but this is what will happen, right? Is it clear? Confusion? No confusion? Okay. Now this is the basically start of this polymorphism. If you look at, actually this is called as ad hoc kind of polymorphism. When we talk about this operators like a plus star and all, which allows you to combine this type of different type of operands, okay, and giving rise to a specific type of operand, okay, sorry, specific type of result. This is actually is a kind of polymorphism, because there can be the star has many forms here, right? Star has many forms here, and we are getting this particular result here as part of this defined kind of operands or types of operands for that star, and the rules that are defined for that particular thing. Clear? Okay. This is one kind of polymorphism, and it is generally called as ad hoc polymorphism. We will see that later. It is not a yes, there are many forms, and you can languages like C++ and Ada, they allow you to define in fact operators. Okay, so you can define let us say star, where you can say that okay, I want to multiply two matrices. I define my multiply operator with two matrices or one matrix and another scalar, right? I can define that part, and so those languages like C++, Ada, they allow, Java does not allow you to define the operators, but definitely there is a different way of doing certain things, and that is that exists because this kind of they have their own libraries most of the time that is typically required, and that is the reason they have not added till now, and a guy who is original author of or writer of this Java, he is strongly against operator overloading, the user defined operator overloading. Anyway, so let us move to the next part. This till this point is fine. Now we are getting into the polymorphism as such, okay, but before that let us revisit again. Let us go back to our different types and all this thing, because we are not just talking going to talk about the star and plus kind of ad hoc polymorphism. We need to look at more about the different aspects and different kinds of polymorphism and how it evolved and how basically it actually is represented, or it can be represented in programming languages. Okay. So I am just mentioning here first order type system. Whenever there is, we mentioned in the last slide that there is a type variable. I added a type variable, right? So that type variable in the first slide I gave that two exercises where there was the T type variable, and then the last slide also we talked about that alpha, beta, gamma, which represent maybe a float plus this one x, y, z, etc. And that is basically, I said that it is basically a variable. The type can be either of that. Okay. So first order type system, there is no variable. there is no variable, okay. And so that is basically the these are the normal initial languages, all these languages like Pascal, Algol 68 etc., they started with that. But obviously lot of functional programming languages during that period, they started introducing second order function where there is a type variable was introduced, okay. Now here I am saying it is a very simple way to define this particular semantic of this first order type system, okay. And for the second order there is a definitely you require in fact to consider certain other things actually. So there is no type parameterization, there is no type abstraction like number for int or float or class, sorry, number for int and class, you are not mixing this thing, or class is not there, then in that case it is a basically first order system, okay. And these are the typical types that you will find in programming languages, like maybe a type void in case of Java also, okay. Then there is a associated with that, there is a in fact null is not a value of void, but null is itself type by itself actually. You can call it as a more of a unit type as it is called, but it can be mixed with different reference types, correct. Okay, let us go to the next part directly to the this product types and the union types, okay. This is also you have in case of C and C++, there is a struct that is there. That struct is a basically product type, okay. Most of the time that struct actually is a labeled product type because you give a name to that particular structure, correct, record. So record in case of Pascal, those of you know Pascal, that is basically a product type. Java directly introduced class, so we will not, it is a kind of, if you use it in a not in an object oriented way, it can be considered as a product type, but it is a, we will not touch upon that controversial statement. So let us keep it that aside. So product types are basically what happens is that the type of pair of values, okay, where the first component of type A and second component of type B, there is also something, sometimes you can form the tuples out of that, okay. Union types, there is another in C it is a tagless union, but in case of Pascal, Ada, there is a different kind of unions that exist, we will talk about that. And this kind of basically types were first introduced in these languages before all this polymorphism and all this got introduced. And in fact that is a, they are very important because what happens is that if I am saying that the record actually this product type is representing, let us say, a person, representing a person. Now person becomes a, I want to say that a person becomes an employee, what I need to do? Do I need to redefine that? So all these basic types, actually first order type system was important actually, and that's on the basis of that, on top of it all these things evolved actually, okay. So we need to consider this, we need to understand that them in a really in a systematic way and effective way. Let us take an example, I will just those of you, I mean I just want to in fact touch the basic parts and then we will get into the slowly into the more things because it will become much easier. Here if you can see that this is a Pascal example, and here how the, because our course is actually about the programming languages, okay, it is not a particular programming languages. So I have chosen the examples from different languages, okay. Sometimes I will also show you about how the Ada actually in fact has certain features, just now we will see that actually. So this is a Pascal example where you are defining the what is called as the labeled product, okay, labeled product. And if you look at this is a passenger is defined as a record with name and flight, and here a simple thing, that very interesting part, the kind of basically statements that evolved and the kinds of type expressions that are required. For example, Pascal allows you to say that with the customer is, let me use this, okay, the customer is of this particular passenger type, right. And what we are saying here is that you can either use this way, or you can use this with the customer and then this part, got it. Very interesting actually, because all these languages, the way they evolved, okay, and okay, now let's look at the other aspect, which is a labeled union, which is a variant type. It is called variant type. Okay, this variant type, if you look at there, what we are saying here is a boolean, okay, case boolean false, then this particular part. There is another variant type that is shown here, which is a labeled. This is the unlabeled, okay, this is labeled, and this is like your C kind of union, okay, this almost becomes a C kind of union. This is a basically a labeled, where we are saying use polar colon boolean. That means you have to set the value of use polar, and then only you can set the values of this. If use polar is false and you try to assign to r or theta, then it will be considered as an error. So this particular part, this kind of labeled products and unions, record and variant types, they in fact, there is a much more in some of the languages like Ada. Okay, for example, Ada allows you to have what Ada calls it as a discriminant type, and you can say that type buffer size equal to 100, then we can actually use that size, which is a parameter, to define the particular field of this size as such. Okay, so this is there is a difference between these languages actually is important. Now, if you observe here, I am here using a one more, and this is going to, we will talk about this as before we talk about the polymorphism, we will talk about this particular kind of language evolution, type evolution and type system. See here what we have written here is that type square side colon integer is new matrix record. So what does this particular thing indicates? That there is a something I am defining, there is a base type, and I want to derive from that type. This is not inheritance, this is called as a derived type. We will talk about that more, because this is going to be important for our, when we say that the polymorphism also was introduced from this angle, that there is a base type and we have a derived type, okay, and then derived type will in fact inherit the operations of that base type. Okay, we will, but there is a difference there, we will talk about that more later. So this I will just not go into the details, but yes, I mean there is a different ways of in different languages. Ada again has a similar kind of thing as Pascal. Now, do you know what is the advantage of this union and variant type whenever we talk about the actual storage? Whenever you are if you are using, if you do not use this variant type, let us say, if you do not use variant type, obviously you can still use that product type and represent it to variant type. Am I making sense? You do not need to, why you are using this particular variant type? If I want to represent, let us take an example here, payment type. If I want to represent the payment type, if you look at on the right hand side, there is a payment type here, correct? Cash, check or credit, and we are saying that this is a record. This record is basically, it is a variant type, where the variant is actually defined using this discriminant. It is called as a discriminant. What we are saying is that the type, if the type of the payment is a cash, then this particular field becomes active. What we are saying here, this field becomes active. When the type is check, then this field is active. When the type is credit, then these fields become active. Now, if I do not use this particular discriminant and I can use that as a one of the field member, I still can represent this particular union variant type using the product type. I can do that, right? So, actually the correctness of my solution, correctness of my program will be in fact, I need to ensure that. I need to ensure every time whenever I use check number, I need to ensure that yes, I am using a check number when the payment type is check. I need to ensure that. Now what is happening? Your type system defined by that language, okay, it is going to ensure that okay, your usage of check number, you will get a exception, we will see that later, or you will get an error if you try to use a check number when your discriminant type D type is not check.